So, very good morning all, welcome to SAKALAVIDYA YouTube channel. Okay, Sanvita, Chandana, okay, Venu. Today many new Pragada Jyotishwari, Bilvika, Deepthi, Chintu, Ruchita, Sanjeev Kumar, Vaishnavi Vinayaki, Sudha Ganniri, Ashwa Reddy. Okay. Right, next Gudur Mohanavamshi, Mukesh Vandanapu, Surya Prakash, Venu, Murali Mohan. So, I think today more new viewers are there. So, I suggest you please subscribe to our channel and like and share. So, if you just subscribe it, you will be getting our notifications regarding our live classes. B. Lokesh, Harichandra Prasad, you are also new. Jay Vishnu Madhuri, Samir SK, yes, you are regular. Madhurima, very good morning. Sunitha Bhandari, Behera, good morning. Nagalakshmi, Prasanna, good morning. Raju, good morning. Okay, Raju, good morning, Ashwin, good morning, Ashwin. Vishnu, okay. Okay. Balakoti, Vaishnavi, good morning. Rakshita, you are new to today our class. Next, Kulwant is not actually regular. Mirja Fazim, you are new. Danusha, Ashwin, Harishita Sai. Okay, thank you Vanadal, thank you. Mamata, Ashwaradi, hi. I think you have been waiting for 1 hour, I think so. Okay, Yogendra Kumar, right. So, first yesterday we have completed trigonometric equations. Okay, next today we will concentrate on inverse trigonometric functions. Okay. So, in this first I would like to concentrate on the basics and concepts on inverse trigonometric functions, the first hour. The next hour, okay, we discuss the problems on inverse trigonometric functions. So, that will be continued. So, tomorrow and day after tomorrow we shall complete the inverse trigonometric functions. And next, Suha Kumar, actually you can take leave on Sunday. Every day we have Sunday, isn't it now? We have less time. Okay, good morning. Thank you sir for new chapter. Okay, Sai Kiran. Okay, let us start. Sreha, have you subscribed? So, first inverse of a function. What is the inverse of a function? So, what are the conditions are to be satisfied to get inverse of a function? So, inverse of a function. For example, let us consider f maps a to b is a function. Suppose, in order to define the inverse of f, so first actually f should be, f is 1 to 1, and second point, f is onto, that means we can say surjection. Then we can say that f is bijective function. Bijective function, that means if and only if f is a bijective function, then f is inversible. That means f inverse, the inverse of f exists. Inverse of f exists. So bijective means one to one function and onto function. So understood now. So that means in order to exist inverse of any function, it must be one to one and onto function, that is called bijective function. So then here inverse of f exists. Generally, for example, the inverse of f is denoted by f inverse x or f inverse function. That means f maps a to b is a function, then f inverse b to a, f inverse maps b to a is called inverse of f, providing these conditions. It must possess these conditions. Okay. So the okay, now voice is clear. Wait now. So voice is clear. Okay, thank you. So that means now we can conclude like this now. So we can conclude like this. F maps a to b, is bijection then f inverse b to a exists and f inverse b to a is also a bijection. In functions we have studied this theorem, is also a bijection. So now let us discuss one note. So all trigonometric functions are bijections. Now let us think. All trigonometric functions are bijections. For example, you consider the functions like this: f of x is equal to sin x, or you can say cos x, or you can say tan x. Even cot x, secant x, cosecant x are reciprocals. Let us confine to these three. Or these functions are bijective, or these functions are bijective. Just think, or these functions are bijections. Sorry, you said bijection but you wrote function. Yes, f maps a to b is a bijection, then f inverse b to a exists, and that is f inverse b to a is also a function. Function means also a bijection. Okay, okay, here bijection is also a bijection. Okay. So, now f of x is equal to sin x, cos x, tan x. So, let us have a discussion here. So, domain and range of these three functions let us write. Here first function, for example sin x. What is the domain of sin x? That is all real number system R. The range will be -1 comma 1. So, cos x, what is the domain of the cos x? It is the real number system R and range is -1 comma 1. Next tan x. So, what is the domain? So, domain will be actually here R, but range will be -infinity to infinity, but this will be R minus 2n plus 1 pi by 2, odd multiples of pi by 2. So, this need to be deleted. Okay. So, that means now if you want to define, yes, for example, see sin x, for example, is a sin x function. For example, a to b, we define sin x function. This is actually R, here f. So, here range is actually, so -1 to 1 dash dash 1. Here we have all the real number system. So, that means for example, here f maps a to b is not 1 to 1 function, is not 1 to 1. So, not 1 to 1 means it is many to 1 function. That is why this sin x, cos x, tan x are not actually inverse functions. Okay. So, that means now unless and until we restrict the domain, these domains are to be restricted. If you restrict these domains, then only we can define the inverse of sine, inverse of cosine, inverse of tangent can be defined. So, that means first for here very important point you need to remember. Okay. Note, all trigonometric functions are not bijections. Since they are not bijections, we cannot define the inverse function. That is why we need to restrict. To actually define inverse of trigonometric functions. We need to restrict the domain of the functions. That means now we just actually restrict the domain, then we define all the inverse trigonometric functions. Now, let us see how can we define the inverse functions one by one. Let us have a discussion now. Here see, First one, the function f maps minus pi by 2 comma pi by 2. Instead of r, just we confine to this interval itself only, minus pi by 2 comma pi by 2 to minus 1 comma 1. That means here domain is minus pi by 2 comma pi by 2 and range it will be up. It is quite obvious that minus 1 comma 1 defined by f of x is equal to sin x. Sin x is a bijection. Now it is a bijection now. As the domain has been restricted, now this sin x is called actually inversible sine function. Here sin x is called inversible sine function. Okay. So now the f of x is equal to sin x is a bijection. The inverse of f, the inverse of f, the inverse of f from minus 1 comma 1 to minus pi by 2 comma pi by 2, pi by 2 is also a bijection, is also a bijection, is also a bijection. Now this function which is defined from minus 1 comma 1 to minus pi by 2 comma pi by 2. So now the function is called inverse of inverse sine function, inverse sine function denoted by sine inverse x, or we can say that arc sin x. In some textbooks it may be written as arc sin x also, arc sin x. So that's I am not discussing about the functions here. One thing remember, so the range is equal to the codomain, that's onto the concept of the onto. So let me confine to the only inverse trigonometric functions. Okay, what's your doubt? Actually Sheikh Mahbub Hussain, please actually once again type it. Okay, chart in our chat box. Okay, one thing remember, here inversible sine should be written as capital S sin x, start with capital S. If you write small sin x, the range is domain is R only. That means you need to remember, whenever you write this sine inverse x, compulsory you need to use capital letters. You must remember, begin with capital letter. That is the difference between the circular trigonometric functions and inverse trigonometric functions. Please, actually in the textbooks they are using even small also, but in general we should not use that symbol. That's why I have written actually here, see here capital I have written. That capital sin x means that is the inversible sine, the inverse of the sine function we can find out. So here for example you can say y is equal to inversible sine sin x. So that implies if and only if x is equal to, we can write sine inverse y, sine inverse y. Okay, next now. Second one, the function f maps 0 comma pi to minus 1 comma 1 defined by f of x is equal to cos x, capital C, this is cos x is a bijection. So that means is a bijection means it is a inversible cosine, it becomes inversible cosine. Okay, bijection the inverse of f from minus 1 to 0 to pi is also a bijection, that means inverse exists. So this bijection function, the function is called inverse cos function or inverse cosine function, inverse cos function, denoted by cos inverse x or arc cos x. Suppose y is equal to cos x, inversible cos x, then we can write x is equal to cos inverse y. So that means actually here the domain has been restricted, to here 0 to pi. In general for cos x domain is R, that has been restricted to 0 comma pi, so as to remember the inversible function. Okay, understood now? Okay, so now let us move to next third one. The function f maps open minus pi by 2 comma pi by 2. Here domain has been restricted to only this interval minus pi by 2 comma pi by 2 to real number system R, defined by f of x is equal to tan x, capital T. This is called inversible tangent function, is a bijection, the inverse of f, from real number to minus pi by 2 comma pi by 2 is also a bijection, Okay, this function is called is called inverse of tan function. Denoted by tan inverse x or arc tan x. So this is the okay, right. So setting, yes, 360 better you will be getting. So this is actually we have discussed. In the similar manner actually we can discuss for even cot x, secant x, cosecant x also. I don't discuss, only 3 have been discussed because these 3 are very important. Inversible sine, inversible cos, inversible tan. Understood now? So what is the domain of inversible sine? So that is minus pi by 2 comma pi by 2 closed. What is the domain of inversible cos? Closed 0 comma pi. What is the domain of the inversible tan? Open minus pi by 2 comma pi by 2. So now let us list out the domain and ranges of the inverse trigonometric functions. This is very important. Based on this, one question will be asked from functions as well as this chapter also. So now domain and ranges. Domain and ranges. So first serial number, function, next domain, range. Please note down, these are actually memory based questions. So Raju, one thing you do it, are you able to hear my voice? Are you able to understand my voice? Everybody getting my voice? Please type it on the chat box. It's clear? Voice is clear? No. So there is a net problem with you. Voice is clear? Voice is clear. Okay, thank you. Okay, thank you. Okay, thank you. Okay, now the serial number 1, function is here sine inverse x. Domain has been restricted. This is very important. Minus pi by 2 comma pi by 2. Range will be minus 1 comma 1. You remember this one. Now the second function, the cos inverse x. What is the domain of the cos inverse x? It is being restricted to closed 0 comma pi. Here range is just like sin inverse x only, minus 1 comma 1. Am I correct now? So next, third one is tan inverse x. Tan inverse x is open minus pi by 2 comma pi by 2. This is actually, sorry, wait. Domain, you can take any real number. Okay. So 1 minute. I will check it now. So, for inversible function I have written not like that. So, 1 minute. See, are you getting or not? Wait, now I will check it here. Domain of tan, right, domain of tan or tan inverse. Okay. Sine inverse x domain is -1, 1. Range will be -π/2, π/2. Cos inverse x is -1, 1. Here the range will be 0, π. You must remember one thing. Here sin inverse x means x takes the numerical values, the sin inverse x gives us angles, you remember. Here the input is value, output is angle, numerical value, that you remember like that. So, tan inverse x is, it takes all the real values, but it gives in between -π/2 to π/2 angle it gives. So, now the fourth one, cot inverse x. Cot inverse x is capital R, total real number system, but it is actually open 0, π. See, this is co 0 to pi, this is co 0 to pi. Tan inverse and sin inverse x will have the same range, will be somewhat identical, same. So, next fifth one, we cannot say same, but sin inverse x range is closed, but whereas tan inverse x is open, that is all. Okay. Next, secant inverse x. So, secant inverse x is equal to, we can write this one, capital R minus here -1, 1. This will be 0, π minus π/2, excluding π/2. So, next sixth one is cosecant inverse x. This also same, capital R minus -1, 1. This will be open -π/2, π/2, but 0 should be excluded, minus element 0. So, this is the domain and ranges of the function, you remember. So, please note down, it is clear. Thank you. Okay. Okay. Please all of you note down this one. Properties of, this is very important for solving the problems. Properties of inverse trigonometric functions. Inverse trigonometric functions. Properties of inverse trigonometric functions. So, yes, is it useful too for Ecet? Wonderful. It is very important for Ecet also. So, you can check your previous papers. So, okay. So, the first one now. So, this is the sixth concept actually we are going to discuss. In that first let us discuss one, sine inverse of sine theta. Here theta is the angle. Sine inverse of sine theta is equal to, you get theta. But this theta must be in this interval. But theta belongs to minus pi by 2 to pi by 2. So generally the one must be tempted to write whenever sine inverse of sine theta, immediately they will write theta. That's absolutely wrong, because the one question you might have come across, sine inverse of sine 2 pi by 3 is there. So what's our answer, anybody? What is this answer? What is the answer of sine inverse of sine of 2 pi by 3? So you need to respond. What would you discuss ellipse chapter? So I didn't get your question. Please type once again. So Madhuri is 0. Sine inverse of sine 2 pi by 3 is 0. Not 0. Video clarity ledu. It will come later. 2 pi by 3 is wrong. Absolutely 2 pi by 3 is wrong, because 2 pi by 3 means that is 120. The 120 does not, actually 2 pi by 3 does not belongs to this closed minus pi by 2 comma pi by 2. So this we should not write 2 pi by 3. It is not 2 pi by 3, wrong. Okay. So that means pi by 3 may be there, that we will discuss later. When would you discuss? Okay, I will discuss you later, don't worry. I will discuss ellipse chapter also. Okay, it might be pi by 3, whatever it may be, 60 degrees. Okay, wait. So now we shall discuss these concepts later, don't worry. But first let me complete the concepts first. So next, in that only, cos inverse of cos theta. Cos inverse of cos theta is also theta, but you need to remember here theta range, theta domain. So theta belongs to 0 to pi. It may be 0, it may be pi, in between 0 to pi. Next, tan inverse of tan theta. So this equal to theta for every theta belongs to open minus pi by 2 comma pi by 2. So actually this plays very important role. And next we shall discuss second one in this one. So now sine inverse of cos theta, what do you get? Sine inverse of cos theta is equal to pi by 2 minus theta. But here for every theta belongs to 0 comma pi. And next, cos inverse of sin theta is also equal to pi by 2 minus theta, but for every theta belongs to here minus pi by 2 comma pi by 2. So next we have tan inverse of cot theta. Tan inverse of cot theta equals to pi by 2 minus theta. For every theta belongs to, you can expect it now, theta belongs to open 0 comma pi. Next, cot inverse of tan theta is also pi by 2 minus theta. For every theta belongs to minus pi by 2 comma pi by 2. Okay. It is useful to other competitive exams. Yes, why not? it will be useful for any competitive entrance examination. Okay. Bhargav, it's your network problem, the video is clarity. Yes, correct. Okay. Yes. Yes. Thank you. Thank you. Thank you. Right. So, let me continue. Next, we shall discuss the seventh concept. Seventh concept, sine of sine inverse x. Here x is a number, you get x for every x belongs to minus 1 comma 1. Because for example, you are asked this question, sine of sine inverse 2. 2 is in radians, you remember now, that means 2 cannot be possible. So, thank you, thank you. Next, cos of cos inverse x. Cos of cos inverse x is also x, but provided for every x belongs to minus 1 comma 1 only. So, next tan of tan inverse x equals to x for every x belongs to any real number r. Okay, now let us discuss eighth concept. It is very important. Sine inverse of minus x, just like sine of minus theta. Sine of minus theta is equal to minus sine theta. In the similar manner, here sine inverse minus x is also minus sine inverse x for every x belongs to minus 1 comma 1. And but here very important, cos inverse of minus x is not equal to minus cos inverse x. Sir, I didn't learn the previous topics, I came from the fifth topic, then what about my previous topics? So, cos inverse of minus x equal to pi minus cos inverse x. So, for every x belongs to minus 1 comma 1. So, always I suggest you, my friends, one thing you remember, whenever s completed, cos inverse of minus x is equal to pi minus cos inverse x, trigonometric equations means level 1, level 2 problems have been completed, still we have level 3 problems. So, all the level 3 problems I will discuss at a one time, do not worry. Okay. Revise previous videos, definitely I will revise, The cos inverse of minus x, this is very, very important. You remember this one, this is very, very important. The cos inverse of minus x is equal to pi minus cos inverse x. Okay. So, next is even tan inverse of minus x is also minus tan inverse x. So, for every x belongs to R, for every x belongs to real numbers. So, next remember cosecant inverse of minus x, that is minus cosecant inverse x. So, for every x belongs to R minus open minus 1 comma 1. Right, Ashwaradi, good suggestion you have given. Right. Playboy money, definitely I will give Ecet. This is very, very important for Ecet, Nana. You go through your Ecet syllabus, same concept. Concept is everything is same for all entrance examinations. It's same only. So, now cot inverse of minus x, this is pi minus cot inverse x. Okay. So, this is for every x belongs to R. So, next secant inverse of minus x, pi minus secant inverse x for every x belongs to R minus 1 comma 1. So, you need to concentrate on this one. See the cos inverse minus x and cot inverse minus x and secant inverse of minus x. Okay, thank you. So, revise the previous video. So, now I have been continuing in the middle of the chapter. How can I revise it? Definitely I will revise it later. Okay. Next, ninth concept. What is the ninth concept means? Sine inverse x is equal to cosecant inverse of, just like reciprocal, 1 by x for every x belongs to minus 1 comma 1, but x does not equal to 0. This need to be satisfied. When will be the Eamcet exam, sir? Reply: it may be conducted in the month of May or June. I am studying degree first year, sir, but I want to write this Eamcet exam this year. All the best. May God bless you. Yes. Cos inverse x is secant inverse of 1 by x, you can write it. So, for every x belongs to minus 1 comma 1, but x does not equal to 0. Next, tan inverse x. So, tan inverse x is equals to cot inverse of 1 by x provided x greater than 0, positive. So, this equal to minus pi plus cot inverse 1 by x, okay, when x less than 0. So, this you need to remember. So, I am discussing very crystal clear about the concept. Next, we have the 10th concept, sine inverse x plus cos inverse x equal to pi by 2. Here, for every x is a number belongs to minus 1 comma 1. So, now tan inverse x plus cot inverse x equal to pi by 2. Here, for every x belongs to R, secant inverse x plus cosecant inverse x equal to pi by 2. Here, for every x belongs to R minus open minus 1 comma 1. So, these are very important. The 10th concept is generally this will be useful for even integration, differentiation, and everywhere it will be useful. You might have seen in differentiation also, even limits chapter, it will be so useful. This 10th concept is better to concentrate. There is a possible to write for degree students to enter into the BTech. Why not? Actually, after completion of your BSc Mathematics also, you can appear for the engineering courses. You may be admitted in second year. Yes. So now all the new subscribers, new viewers, you need to subscribe first. Okay. Now the most important concept to be discussed now, that is 11th concept. Please note it down, this will be very, very useful. Tan inverse x plus tan inverse y equals to tan inverse x minus y upon 1 plus xy conditions. X must be positive, y must be positive, or xy is greater than 0 also we can write, but xy should be less than 1. Then you need to apply this one. Same only, pi plus tan inverse x minus y by 1 plus xy x is greater than 0, y is greater than 0, xy is greater than 1. Greater than 1 means you remember pi to be added, that's all. So this is actually, this is not the enquiry session, Mr. KK Pavan, you remember. This is the academic session. I don't have any idea about your results. Okay. Right. Better relax. What Surya Prakash said, that's correct. Can you explain the domain and range concept, please, sir, in functions? Why not in functions? Definitely the functions only based on the domain and range itself only. That's there also I will clearly discuss. Okay. So next we have, this is equal to minus pi plus tan inverse x minus y by 1 plus xy. Okay. Here both x less than 0, y less than 0 and xy is greater than 1 and equal to absolutely, for example, pi by 2. So when x into y is equal to 1, the product of these two is equal to 1. So please note down this one, please note down. Here x plus y, x plus y, x plus y, sorry, absolutely. Here we have yes, because tan inverse x plus tan inverse y, you get 1 minus, here 1 minus, 1 minus. So now note it down. Okay. Okay, I will repeat. Tan inverse x plus tan inverse y equals to, so tan inverse x plus tan inverse y equals to simple tan inverse x plus y by 1 minus xy when x greater than 0, y greater than 0, xy less than 1. I will explain one problem to you. For example, tan inverse 1 by 2 plus tan inverse 1 by 3 is there. You check. For example, let us say this is x, this is y. X is positive, x greater than 0 and y greater than 0. Xy, product of these two, 1 by 6, xy. that is less than 1. Now, then you can apply this one now. This is equal to tan inverse of 1 by 2 plus 1 by 3 upon 1 minus 1 by 6 you can write it. So, this equal to tan inverse of this will be 3 plus 2, 5 by 6 and 5 by 6, 1, that is equal to 45 degrees. That is answer. Okay. Sir, will you cover today only Bobby's gaming reviews? Today only you joined. How can you ask this question? Sir, will you cover all the syllabus within this gap? So, it is not a gap, it is a continuous process. Mine is not commercial. Mine is not commercial to complete the syllabus. Mine intention is to give the concept. That is all. Understood now? Sir, degree is the best, BTech is the best. So, that depends upon your interest. How can I say that BTech is best and degree is best? So, if you are interested, the BTech you can join, even degree also you can join. Okay. You may be Ketan, but Bobby's gaming reviews. Right. So, now I shall move to the 12th concept now. Twelfth concept. Tan inverse x minus tan inverse y equals to tan inverse x minus y upon 1 plus xy. Am I correct now? Okay. Here xy is greater than minus 1. This equals to pi plus tan inverse x minus y by 1 plus xy, x greater than 0, y less than 0, and product of these two is less than minus 1. Okay, this equals to minus pi plus tan inverse of x minus y by 1 plus xy. Okay, x less than 0 and y greater than 0 and xy less than minus 1. So, generally in this case we use this one only. The most of the questions will be framed on tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy. But in addition to these, actually 1 year gap vachina exam rayocha. Why not? Even if you get 58 years old also, even 99 years old also, because now we are 99 years also you can appear Eamcet examination. No age restriction. I am new to class. Can anyone tell me the timings? Okay. So many of our subscribers are there, they can explain to you, don't worry. Right. Next concept is, so 13th one, sine inverse x plus sine inverse y equals to sine inverse of x into root of 1 minus y square plus y root of 1 minus x square. Just I have given the formula. Conditions are necessary for this one. No condition for x and y in case 1. Okay. Yes, leave it, no problem, that is why. Right, sine inverse of x into root of 1 minus y square plus y root of 1 minus x square. Here also we need to discuss the conditions, but these questions will be given in differentiation or integration. When you differentiate, the condition means the constant will be 0, that is why need not be required. Okay. So, next one we have cos inverse x plus cos inverse y in general these kind of problems will be dealt using sine of a plus b or sine of a minus b or cos of a plus b or cos of a minus b. So, this equal, but only when they ask the formula, that is only we need to apply xy minus root of 1 minus x square into root of 1 minus y square. This is nothing but this cos a cos b minus sin a sin b form itself only. Okay, next 14th one. These are also very important. Already we have discussed in derivatives. Once again I repeat for the sake of new viewers, for the benefit of new viewers, new subscribers. 2 sin inverse x is equal to sine inverse of 2x into root of 1 minus x square. So, 2 cos inverse x equals to cos inverse of 2x square minus 1. 2 tan inverse x is equal to, this is very important. Generally the most of the time we use this concept, equal to tan inverse 2x by 1 minus x square equals to sine inverse 2x by 1 plus x square. This equals to cos inverse of 1 minus x square by 1 plus x square. Okay. Next, today there should be more likes, I think so. I will be getting. Next concept is 15th concept, 3 sine inverse x equal to sine inverse of 3x minus 4x cube. 3 cos inverse x equal to cos inverse of 4x cube minus 3x. 3 tan inverse x equals to tan inverse of 3x minus x cube by 1 minus 3x square. This will be very useful for differentiation and integration. 1 minute silence for we had disliked the video, sir. Okay. Let them dislike. No problem. So they need to understand we are doing free service. That's all. I already told you need to join in our mission also. Now you become part and parcel of our SAKALAVIDYA YouTube channel. That you do not know. Okay. So first subscribe Shobha. Okay, 16th concept. If x, y, z have same sign means whether simultaneously they may be negative or they may be positive. I already told you, even we completed degree also, they can appear Ecet, not Mcet. Better, they can be admitted in the second year. I think so. I may get nice marks in maths. Okay, why not Shreya Rachakonda? Definitely will be getting. Have you been watching regularly, Shreyana? Type it. So will you tell these concept problems? Sir, will you tell these concept problems? So after completion of the concept only I will teach you the problems, because the first initially I started directly problems. Actually everybody requested me, sir please first initial 1 hour 2 hour please discuss the concept, then go for the problems. That's why I changed my strategy. So otherwise, hello sir, how are you? Who are you? First of all, Rosia, I am very fine. What about you? Okay, which chapter is this? You don't have the Borra Venkat, you don't have the idea. Okay, you might not have the idea. So now get it. This is trigonometric, inverse trigonometric functions. Yes sir, from day starting I am seeing I did not miss any class, sir. Thank you, Sreyana. How do you feel, Sreyana? What about? Thank you. Inverse trigonometric functions. Yes, school one, you are so active. Thank you. Okay. Same sign and xy plus yz plus zx is less than 1. So then tan inverse x plus tan inverse y plus tan inverse z equals to tan inverse of x plus y plus z minus xyz by 1 minus xy minus yz minus zx. This remember. Okay. So this will be, link will be given, don't worry. Okay, Yogendra Kumar, you are new, I think so. So this is the 16th first concept. So in that 16th, let us discuss here only the second concept. What is the second concept here? Tan inverse x plus tan inverse y plus tan inverse z equals to 90, because they are the angles pi by 2. Then xy plus yz plus zx equals to 1, because suppose if you put here 1 minus 1 is 0, something by 0 is not defined, so you get pi by 2, this value. Okay, next concept we have third concept under 16, tan inverse x plus tan inverse y plus tan inverse z is equal to pi. Then you can expect x plus y plus z is equal to xyz. Okay, I hope you will be noting down. Okay. Okay, I will wait because everybody is noting down. Wonderful. So today you do one thing, go through all the concepts. Tomorrow onwards I will start the problems. Already today is the Sunday. Let's take a rest for a while, and evening classes are there. Okay. Thank you. Thank you. So next, this time important tips. Important tips. Whenever these problems are there, directly write the answers. Now I will discuss important tips. Okay. So Sreyana, how do you feel about our classes? Okay. You need to type. Preeti. Right. The first concept in this one, first concept. Okay. Now link is given, all of you join. Okay sir, take rest for some time, after you will start. Okay, right, very nice, thank you, thank you. So tan inverse, these questions may appear in the examination. Tan inverse A by x plus tan inverse B by x equal to pi by 2. Then here in the examination, A value, B value will be constants, will be given, and you are asked to find out x value. Then we have the shortcut, then x square is equal to AB, or x is equal to root AB. X is equal to root AB. X is equal to root AB. Okay. Check it again. Okay. So now the second one also very, very important. Sine inverse A by x plus cos inverse, sine inverse only, sine inverse B by x equal to pi by 2. Then x square is equal to a square plus b square, or x is equal to root over a square plus b square. Okay. Next, third concept. So I will discuss with Prithvi, I will discuss with our technical team, because somebody might have blocked it. Some miscreants are there. Generally they are entering our classes and they are doing a lot of disturbance. Okay. Right. Tan inverse P by Q plus tan inverse Q minus P, not P, by P plus Q is there. Answer is always pi by 4. So tan inverse P by Q minus tan inverse of P minus Q by P plus Q. This is also pi by 4. Very simple. If you take minus sign here, it becomes only third one only. Okay. Now fifth one, tan inverse 2 plus tan inverse 3. So, this is tan inverse x plus tan inverse y formula. Are there proof? Yes, we have the proofs for each and every one. We have the proofs, but again, if I if I give the proofs, it may take 2 months, 3 months time to complete my syllabus. If you wish, you try at home, your home. Without proofs, we cannot write it. So, this is 3 pi by 4. Next, sixth one. For this one, add tan inverse 1. 1, 2, 3. Tan inverse 1 plus tan inverse 2 plus tan inverse 3. See, it is very logic. 3 pi by 4, tan inverse 1 is pi by 4, 4 pi by 4, pi you will be getting, that is all. So, now seventh one, you remember seventh one also. Seventh one is very lengthy one, better you remember it. Sir, you have any Instagram account? I want to share about this SAKALAVIDYA. Excellent classes by Murthy sir. Sir, please tell sir. Kurva Bharati. Actually, I don't have the idea. Okay. So, tomorrow evening definitely I will share it. Okay. Cos inverse x by a plus cos inverse y by b, this is standard question, please remember, equal to theta. Then in board examination this will be given under 7 marks. X square by a square minus 2x y by ab cos theta plus y square by b square equal to sine square theta. This you need to remember. And next one, sine inverse x by a plus sine inverse y by b equal to theta. Then x square by a square plus 2xy by ab cos theta plus y square by b square is equal to cos square theta. So, these are the actually concepts we have discussed. If sir gives proofs for all this, we must write the Eamcet exam in 2021. Okay, video not coming. It may come. Okay, Sreyana Rachakonda, I did already. Okay, thank you Vanandal, So, ninth one, tan inverse 1 by 1 plus x into x plus 1 plus tan inverse 1 by 1 plus x plus 1 plus x plus 1 into x plus 2 and plus so on dash dash and so on plus tan inverse of 1 upon 1 plus x plus n minus 1 into x plus n. So, actually this is called telescoping series. So, if you simplify the actually, sir, how much time do you completed? Classes, Murali Mohan, what's your doubt? Okay. Sir, chemistry, physics also please. I will discuss. Okay. Ramakrishna, 12 o'clock, 12 o'clock. Okay, today I will close the session by 11:25 itself only, because tomorrow directly we shall go for the problems. Right. Voice not clear? Okay. Video not coming. Videos, sir, check it please. It may be coming. This is telescopic series. We have, this can be written tan inverse of x plus n minus tan inverse x. This you need to remember. Okay, thank you, bye, see you, all the best, have a nice day, stay safe, stay at home. Thank you one and all. Bye bye.